Hey guys, welcome back. So this is one of the video which belongs to machine learning algorithms. So in this video I'm going to talk about gradient boosting. So as this picture replicates, the whole model works in similar way. Everything will make sense in couple of minutes. So just take a look of this cute picture. There are few small pandas doing their small work and giving to the big panda. Okay, just keep this information. Let's uh, okay, let me try to explain you how gradient boosting works. So gradient boosting is a model where it tries to create small models like small pandas. So it will create multiple small pandas and it will train them. Okay, but in the way, there is a technique where this panda gets trained, and the mistakes that are done by this guy will be rectified by this guy will be trained on this one's mistakes, first one's mistakes. In the similar way, everyone in a sequential manner will try to learn from the previous one's mistakes, and they will try to give an final output to the big panda, saying that okay, this is my final output, what do you think? So the biggest advantage over here is, so we are creating multiple models, and in a way that everything is being trained by the mistakes of the previous one. So you will get a very good outcome, which is nothing but which you will get a very good prediction. And yeah, so that's the main concept of gradient boosting. So let's talk in terms of some technical terms, and now I'll explain gradient boosting. I hope you guys got the concept of gradient boosting by right now. Okay, let's go and see. First of all, there are few things to talk about. It's an ensemble model. Ensemble model is nothing but you are trying to create the final prediction by taking multiple models, by training multiple models and taking the majority vote or majority average or something like that. So as I said, uh, we created multiple models, right? So that this concept is nothing but ensemble technique. uh, Gradient boosting works on this technique. And second thing is, it can be used for both regression and classification. So let me explain you how. So every guy gives an output, right? So for instance, let's say this model says 1, this model says 1, this model says 1, and this guy says 0, this guy says 0, 1, 1, 1. So the majority says 1, right? So the final prediction would be 1. So that's how an ensemble model works. If like in context of regression, you will take the average output. For instance, let's say this guy says 0 0.1, 0 0.4, 0 0.6. All of them say some continuous variable, right? So we'll take the average as the final prediction. That's about how an ensemble tree works. But whereas our gradient boosting is a step ahead. These models are nothing but a decision tree. Each model is a decision tree. Ensemble model has a rule that it need not be any particular model. But whereas our gradient boosting works takes decision trees as the base models. Okay, so I think the concept is clear. Now let's deep dive into some math. So yeah, as I said, first of all, there will be all these models will be sequentially placed. The outcome of this model, the outcome of this model, uh, for instance, let's say uh, this is a base model. This is not a decision tree. Uh, Base model gives the prediction of the average value of the outcome. Okay, I'm just putting average for now. I'll show you with an example to be very simple way. First one would be the average as outcome, but subsequently, for instance, let's say the average outcome is 75 but original prediction is around 60. There is a difference, right? 15 difference is there. So this decision tree or this model uh, takes the input of independent features and tries to predict the residual or the error. Okay, I hope you got the point. Then for instance, let's say it predicted 12 12 as a residual. Okay, then you'll try to subtract this original prediction minus 12, which will give you around 63. So it is close to the original prediction, right? Outcome is equal to, so if you do in the similar way, the model will get clearly overfitted. By creating multiple models, you will definitely get 60 as your outcome. So your model should be generalized. So for that reason, you will try to add a learning parameter for this outcome. So 75 minus some alpha into 12. So this alpha usually it will be like 0 0.1. So 0 0.1 into 12, so that would be 1.2. Your model will give you around 72 as 72 as the outcome. So still there is some work to do. Again, you will calculate the residual, which is 12, and you will try to predict this. So in the similar way, this model will try to predict 12 as the residual of this model. So in the similar way, you create multiple decision trees subsequently and try to decrease this residual. Okay, so I hope you got the concept. So far the concept is clear. Let's talk with a real life example so that it would be easy for you. So as I said, if we consider a small example saying that these are independent features and this is a predicted this is the outcome, and as we were talking, the first model is nothing but average outcome, 5 plus 7 plus 10 plus 12 plus 15 divided by 5. I can't compute all this, but for now I'm just assuming it would be around 8 or 9. Let's say it's 8. So the final outcome would be 8. So the first prediction would be 8. Then you'll try to consider residual, which is nothing but the difference between them. So it's 3, 1, minus 2, minus 4, some 6 or 5, 6 I guess. So then residual is this, right? As I said, you'll assign a parameter for this. So 5 minus 0 0.1 into 3. So that would be 5 minus 0 0.3, which would be around 4.2, right? So the next prediction, the next target variable would be 4.2. In a similar way, you try to calculate all these things, and then you will build an decision tree. I hope you guys know the concept of decision trees. If not, like, go for my previous video where I taught about decision trees. Then you give this independent variables as an input, x's as an input, and try to predict this 4.2s. I mean, like uh, this target variable, and then again you get some kind of residual, right? You will get some kind of residual. For instance, let's say it would be like 1, 3, minus 2, minus 4, something like that. Then you'll try to put that again, you give some kind of learning parameter for that, 0 0.1 into 1, and then you'll get some kind of value. For instance, let's say that would be like 5.2. In the similar way, you try to decrease the residual as much as possible and try to match this target variable. So that's how a gradient boosting works. However, there are few things to remember. One thing would be your model can easily get overfitted if you couldn't take if you don't take good measures, which are nothing but you should not complicate these decision trees. You should find an sweet spot where you should stop the number of trees, because the more number of trees you are getting the exact same result, which should not be the case. You should find a sweet spot where you should be able to stop it. And second thing would be in the context of overfitting, should also take some measures, like you should make sure that this tree is should not be so lengthy. If it is too lengthy, the model gets too complicated and it will give the exact predictions. So your end goal for any machine learning algorithm is to see the pattern, okay, not to fit the pattern. Okay, there is a big difference between fitting the pattern and finding the pattern. So if you fit the pattern, for instance, I'll explain you with a small example. I know I'm going a bit off the topic, but I think it's important to mention. So for instance, let's say this is your independent dependent, okay, dependent variable, and this is independent variable, and you're trying to fit, if you're trying to find a pattern. So this should be your end goal. uh, if you fit the pattern, it becomes like this. So wherever the data points are, your model goes. So you're not generalizing it. So what happens if if you're not generalizing it? Or the data points will not follow the same thing. Okay, there will be unseen data. Your model will not perform any good. For instance, let's say you are not following the pattern. So then, for instance, your new data point would be this. So prediction will say that this is wrong. So in this way, you should make a generalized model. So that's about gradient boosting. I hope I explained in a good way. First, I tried explaining you with a small generalized example, and then I gave you some basic institution, then followed by I gave you some mathematics institution. So if you guys need some in-depth formulation, let me know in the comments. I will put up all the formulations in a document and I will show it to you. I don't want to confuse you, because like there are ton of materials in the internet where you will get confused. So the main objective of this video is to get the basic institution of the model and how it works, so that it would be easy for you and you can take it from there. I hope you guys like the video. Please like and subscribe the video.